Good morning, everybody, and welcome to day 3 of Ignite. Hopefully everybody's having a great conference. And well, welcome. I appreciate your time and efforts coming out today. This is the exam prep for 7532 Developing Azure Solutions. My name is Brian Swiger. I am an app dev manager in Microsoft Premier Support. If you're not familiar with Premier Support, we kind of cover MCS, a lot of different areas as well. We're pretty much consulting, pseudo-consulting within Microsoft. And of course, we engage our partners as well to help out there. Again, Brian Swiger, you can find me on Twitter, CodeBeing, that's my personal website. And you can find me at aka.ms/Brian Swiger. Again, I'm an app dev manager in Microsoft Premier. I've been a developer for 20 plus years. Started out as a government contractor doing C++ for the government. I am a Microsoft certified trainer and solutions developer. I've done a lot of different training courses across the United States. It's a lot of fun. If you ever get a chance, I encourage folks to become an MCT. It's a great opportunity to deliver mock courses, etc. I am an Azure certified developer architect. So these exams, I do dog food them. I take a lot of exams. I do it mainly for learning. I like to learn. It helps me learn. It's not really a badge of honor for me. It's something I can learn and achieve. If there's something new out there, I'm going to go take the exams. I'm really bad at SQL Server. I'm not a data guy, but I went and I take the SQL Server exams. It helps me to study, to get in that mode, and to understand what's going on there. I have been a Microsoft Learning Experiences contributor for 10 plus years. Under NDA, I can't say which exams I've worked on, but I have written, reviewed exams. So you can blame me for a lot of the different developer exams that are out there. So I am that individual. So you've probably seen the exams kind of evolve over the years from the simple ABCD. Yeah, I was part of that experience. So you can blame me for the difficulty of the exams and all of that, adding those items. So I like to contribute to the exams. Like I said, I'm big for these exams for learning, the learning purposes. So in this session, overall, what I want you to do and take away is understanding how to prepare for the exam. So I'm not going to cover everything in the exam. There's a lot of content in these slides. I'm going to go through a lot what's focused on this exam. I'm going to give you as many study resources and materials and my input, just shy of giving you the questions and answers, okay? And the other thing is, essentially, I want you to take this slide deck. Hopefully, we'll download it from the Ignite site and walk away with it. There's several links that I'm going to show you inside of this. If you go out there and read, I'm pretty sure there's a question on the exam that's associated with some of these links, okay? So we'll cover some exam concepts real quick, the exam updates, some of the basics of exams, and then a little bit of scoring. How many folks in here have taken a Microsoft exam already? Okay, perfect. For those that haven't, I do suggest that you do so, just to understand the flow, the process, what it feels like, the number of items, all of that good stuff. And lastly, we'll look at the exam question structure. So the exam updates, a lot of folks ask me, how often are these being updated? They're updated every 3 months. So especially with the Azure exams, we're rolling these updates consistently. And of course, we're focused on cloud-based technologies, especially obviously with the developing Azure solutions. So understand, a lot of times the resources that you reach out to may or may not be 100% on par with the exam. It's a good guide, but it's not going to be on par with the exam 100%. Always my advice, get hands-on. Go get a subscription, which you've noted here at Ignite are now, you can get a free temporary subscription, essentially, to go try these concepts, okay? So the exam, about 40 to 60 questions. You have about 1 to 4 hours to complete that. There's possibly about 20 different types of questions. Like I said, this isn't just straightforward ABCD anymore. You can review the questions, and I highly suggest that you review your questions. You can mark them for review as you go through. And another thing I always encourage, give comments. Those comments that you give on that question are read. They're read by individuals like me. We review them, and we actually take them into account. So if something's wrong or looks wrong on the exam, please let us know. We'll take that into effect, and you may actually get a point for that. We may deduct that, and if there was a problem with the question for some reason, we review that. If you're familiar with a case study, it's kind of a big business solution. You'll have a lot of text, and I'm going to talk about strategies there, because I'm not a very good reader, and it intimidates me a lot of times when we have a lot of text that I have to read. So you'll notice you can't move back from a case study. So if you encounter a case study, it's got a lot of text, it sets up a business scenario, you're going to answer a set of questions for that business scenario. And you cannot move beyond, you cannot move back into that case study once you're complete with that case study. So make sure to read the screens as you're going through. And a big thing, 700 is not 70%. So if you get a 700, be excited about that, because there are different weights for the different questions. Some are harder than others, and we weight them differently. So don't feel bad about a 700. The other thing I tell you, go take the exam. You're going to hear that consistently. Don't be afraid to fail the exam. I have failed many exams. You don't know that. It's not published anywhere. Okay? I've taken tons of exams that I've failed, especially on the infrastructure side. I'm not an infrastructure person. I'm a developer. I've tried them. I have failed them. So it's okay to fail. All right? Like I said, each exam has a cut score. We essentially weight the difference on the questions. So there's a different score applied to that. That's how we come up with that 700 to 1,000 that we're going to get on our final scoring of the exam. Some questions now are worth multiple points. They're going to indicate in the text and tell you they're worth multiple points. And I always tell folks, answer every question. Always answer every question. Even if you don't know, just pick something. Just put something in there, okay? And like I said, mark items later for review. As you're going through it, if you're not quite sure, I always say don't second guess yourself. Absolutely don't second guess yourself on these exams. Don't think too far into it either. Don't think, well, I could do this, I could do that. Only think in the context of the question. You are right here, right now in this question. You are not outside of that question in the world. So focus on that question. You're right there, right now. Don't double second guess yourself, but of course, mark it for review. If you're not quite sure, you don't even want to read it right now, you want to come back to it, mark it for review. And again, comments. I appreciate the comments. So an exam question structure, what does it look like? So essentially, you're going to have 4 different parts. You're going to have the technical environment or scenario. We're going to set something up. You're going to have a problem statement or requirements. So the app must do something, right? We have some requirements that we need to accomplish. And then you need to do something. You need to either pick an order, you need to pick the correct technology, you need to pick the correct code segment, what have you, okay? And then what should you do? Technically, at the end, it's what should you do? What code segment should you select? What order should these properties be in, or what have you, okay? And like I said, do take the exam, please. There's 50% off here at Ignite. It'll be 40% after Ignite. We do have free practice exams. Like I said, they give you a good guide. A lot of feedback that I get is, hey, the measure up aren't up to date, or some of these other areas aren't up to date. I encourage you to use those as a guide to practice and understand kind of where you're at in the thinking, but do hands-on. Do the hands-on labs, go out and do these things. So deploy a VM using PowerShell, okay? And there's more info out here at the Hyatt. So you wander around, you'll see more information. So the exam topics and details, if you go to aka.ms/70-532, that will take you to the Microsoft Learning site. You will see the skills measured area. That skills measured area is going to cover exactly what's on the exam. Do not stray from that. That is your guide. That is what's on the exam. With Azure, there's a lot to Azure, but what is on that skills measured is what you're going to be focused on for this exam, okay? We have other exams. We have 533, and 534 that cover the infrastructure and the architecture area. So this is, again, focused on the developer and the developer topics. So, like I said, these exams are changing. The overall exam outline is that skills measure that I talked about. The 4 key areas right now that we're going to focus on are virtual machines, all using ARM, no ASM. ASM has been eliminated from the exam, okay? Storage, web and mobile, and then identity and networks. Those are your 4 pillars or 4 key areas. Some things that we're thinking about for the exam in the future, always to think about what cross concerns here. DevOps. So DevOps would be something that might get tested in the future, as well as some of the Cloud Foundry or some of the third-party integrations that we do as developers. So those are things to think about, but as of today, these are the 4 pillars. And across those, you see these percentages across here. That is the percentage of questions that are going to be on the exam in those key areas. So when we generate an exam, it is all random. We have a massive pool of questions, and we generate the exam all up front. A lot of folks ask me, does it progress? Does it get harder as I answer this one wrong or do this? No, it doesn't do any of that kind of logic. It's going to grab from the pool, generate your exam, and you're going to get 20 to 25% of your questions are going to be in ARM virtual machines, okay? Out of that pool of questions. So we also have designing and implementing the storage and data strategy. So we're looking at our 4 pillars again. And designing and implementing Azure Compute and web and mobile services, a lot there. That's a majority of the exam. So if I'm looking at studying for this exam, I would probably study that the most because there's 35 to 40% of the exam is on that area. And then 10 to 15% in managing identity, application, and network services. And as a developer, yes, we essentially have to know enough of Azure infrastructure to be dangerous, but yet be a developer and get our jobs done. So starting out, we'll look at virtual machines. What do we need to know about virtual machines as a developer? So overall, with a VM, we need to understand these 6 areas. We're looking at monitoring. How do we essentially monitor a virtual machine? And again, there goes into a lot more depth on the 533 infrastructure exam, but as a developer, you still need to understand that you have these capabilities around a virtual machine. Configuration management, deploying, scaling, storage associated with the virtual machine, and then management actually of the virtual machine. How do I manage the virtual machine? So starting out, your management options, understanding, again, as a developer, everything we can interface with our REST APIs at the end of the day. We also have the command line interface, the CLI, PowerShell, and the portal, of course. And overall, this is a depiction of a virtual machine and the various components. What I would take away from this is understanding what makes up a virtual machine. So I have a virtual machine. It has a NIC, a network interface card associated with it. We do have a couple of different storage accounts. We have a logs storage account. We also have a VM storage account for the actual disks associated with the virtual machine. Okay. We also have a public IP address, and we're going to put this inside of a resource group. That's our bucket of how we're going to group all of these resources together on Azure. So essentially, from this slide, if I were to test you, it's understanding the components that are associated with a virtual machine. So as a developer, if I'm interfacing with a VM, I know I have a the storage account and the logs storage account and the overall components with the virtual machine. So deploying, again, as a developer, I wouldn't expect that you do a lot of this. This would be more the ops folks, so the 533 exam. But as a developer, you need to understand that you can deploy VMs different ways, okay? And you can host them inside and create your own inside the marketplace. You can deploy them using PowerShell code, code of different languages. I don't expect you to know all those languages on the exam, but know that that's a capability. And you'll see here throughout my slide presentation, you'll see these little orange links down here. This is what I was talking about. If you download later on the slide deck, if you go out and read those areas, it will give you a nice overview. And there's probably, again, questions in those key areas on the exam. So here we see, again, the marketplace on the left side, just an example PowerShell command, and then our JSON template, which we'll talk about a little bit more later, for the ARM template or Azure Resource Manager templates. So the ARM templates portal, a lot of folks ask me, hey, do I need to know a complete ARM template? No, but I suggest as a developer you go up to this feature inside of Azure and create a quick template to understand what it looks like. And inside of Azure, on the portal, you can actually create your own templates and add your resources to them. You really don't have to know that complete syntax. I mean, it's massive when you get a humongous ARM template using JSON, but you can understand the general structure of an ARM template, okay? And understand that it is JSON essentially used to deploy all these resources to Azure. So we're going to go ahead and create a template. And our base template has these 4 sections. We've got the schema, the content version, our parameters, and our resources. Those are the 4 general buckets. And we're able to put things into here like a virtual machine. So if I pick a Windows virtual machine, for instance, we do have various quick start templates too. So if you want to set up a SQL Server in a VM, for instance. But you'll notice here, as I've edited the template, it added a NIC and a few other resources just for a standard Windows VM image. Okay, you see that general syntax. So I wouldn't expect you to know every last little bit, but I would expect you to know what makes up a virtual machine. Okay, from a component, you'll see there's a NIC in there, there's a storage account, and what are the general structure of a JSON template? What can I put in there? So parameters, for instance, you see. So those kind of things. So DSC, from a developer perspective, understand that desired state configuration is there. It's an option. It brings the VM back to that particular state. And there is a structure to set that up, essentially from the JSON templates. So if I'm asking you questions on DSC or a business scenario, when would I use DSC? When would I want to use this? I want to bring a VM back to its particular state, or I want to bring up a VM in that particular state. Scaling? You could, exactly. Yep, for the VM scale sets or what have you. So uploading images. So you can create your own VM using your own captured images. Here we have an example. We've captured the virtual machine. We've sysprepped it. We've captured the virtual machine. And we can upload the image and use that image going forward within Azure. Again, as a developer, do I need to know the complete intricacies of this? No. That's more of, again, an Ops 533 thing. But from my perspective, understand as a developer, this can be done, that you can capture an image. So if you're in you're in a business scenario and you need to understand, hey, I can actually sysprep it, I can capture the image and upload and run my custom image in Azure. Availability sets with virtual machines. So we're looking at planned versus unplanned maintenance. So planned, patches, etc. Unplanned maintenance, power failures inside of Azure, a network card goes out, failure hardware, what have you. So we have this concept called availability sets. And we're looking at redundancy. So we're configuring these availability sets for redundancy. We want to keep our virtual machines up and running. And understand that you can combine load balancing with an availability set as well. Okay? And one of the key concepts is our upgrade domains. That's for our planned maintenance. By default, you get 5 non-user configurable domains. They're going to group those VMs, and they're going to be rebooted at the same time. Again, this is for patching purposes. Then you also have the 3 fault domains. This is for catastrophic errors, power outages, what have you, failure of hardware. And by default, again, you get 3 of those. And that's separating the network and the hardware. So from here, a takeaway would be understand that you need to configure an availability set to keep your VM up. If you have a single instance of VM and you haven't configured an availability set, it's going to get rebooted. We're going to reboot that on Azure for a patch or what have you in the OS. So if you don't want that happening as a customer or as a developer user, please configure an availability set for that VM. So storage replication for the VM. We have 4 different areas. We have locally redundant, zone redundant, geo-redundant, and read access geo-redundant. So those 4 storage replication options you should know and understand when to use the different storage replication options. Okay? So locally redundant, you have 3 nodes within the same data center. Zone redundant, we're expanding out again. We have 3 data centers in the same region, so we're replicating our VM storage across those 3 data centers. Geo-redundant, whole different region. We go from the east to the west United States, or where have you throughout the world. And then we have read access geo-redundant. So this is a secondary read-only location. So understand that VMs, again, with the Azure storage, we have those 4 different options. So with VM storage, we have Azure disk encryption. We can go into that a little bit more later, but understand that that's an option. Disk encryption for all of your VMs, whether they're Windows, Linux, etc. Disk caching. So from a developer perspective, again, understand the impacts of disk caching and performance on your applications. You don't have to know the intricacies of the throughput numbers, any of that. I try to make it with exams that you're not memorizing anything. I get upset when I get into an exam and it's something that I'm going to look up on the docs site or MSDN or what have you, or it's going to pop up in my IDE for me. So I'm trying to make it so that you're not having to memorize stuff. So don't feel you have to memorize everything. It's general knowledge and understanding of when to use these different options, different storage replication, when to use Azure disk encryption, when not to, from an application perspective. Understanding your storage capacities, you don't have to memorize all the scalability and performance targets, but understand that that's an option. We have different scalability and performance options in the different sizing, and understanding egress traffic limitations. So egress going out of the data center, not coming into the data center. We have the Azure File Service, which allows for SMB file shares using the file system I/O APIs. So as a developer, again, you can use those APIs to communicate with your SMB file shares connected with your VMs. And then understanding from a storage account perspective, there's premium versus standard. So we're looking for premium for higher I/O intensive workloads, low latency, high performance. So understand the impact on our application of a premium versus standard storage account. Somebody mentioned scaling earlier. We have our virtual machine scale sets. Essentially, as we mentioned with DSC, that would be maybe a good question. How does DSC kind of tie into our VM scale sets? They're an identical set of VMs. It's PaaS-like scaling. So essentially, if you need more compute power, we're going to take that VM and we're going to duplicate it. We're going to continue to duplicate and scale out our VMs. And nearly half of Azure actually uses VM scale sets, if you're not familiar. So Skype for Business, Azure SQL, all of that uses on the underneath VM scale sets. And it is the foundation of Service Fabric. So again, it's PaaS-like auto scale. And you can combine the DSC extension, as I mentioned, along with this. And at the bottom, there's an example, an initial scale set using ARM. So inside of ARM, when you specify your particular capacity, that is what's going to allow that scale set to grow to that particular capacity. So that's it for virtual machines. Any questions so far? Comments? Yep. ASE. No, know when it's used. You really don't have to go into the different options there, when to apply ASE, when not to, or when to use it. It does include questions from a business perspective of when to use, and you're talking about storage encryption? Oh, the actual ASE, okay, with like the front ends and the back ends and all of that. So an ASE environment, you have to understand what it's about and when to use it, but it does not go into great details, no. No. Good question. What's that? Like, no, but again, understand when that's used, not direct usages of it, but it may, include a question of using that or enabling that. But no, there's nothing so far. And correct, yeah, the managed versus unmanaged disk, and that is not currently in the discussions. That the outline doesn't say anything about managed disks. There has been some debate on that, but as a developer, it is good to know that. And again, these are updated every 3 months. I would understand managed disks and the impact of the managed disk. It's good to know on app performance, focused on apps and app performance. Sorry, say that again? Yep. 2.0. Yes, CLI 2.0. So we're going to focus on the newest CLI, and it would be the usages of that CLI. Absolutely. So understanding how to form a basic CLI command, especially for VM rollouts, things like that, automation. Good question. All right, so next area would be storage. What do we need to know from a developer perspective for 532 regarding storage? So you'll see here we have added a couple different things on here, kind of broke them out. We did add Cosmos DB as a storage option. So essentially don't get scared by that. It's mainly when to use Cosmos DB and understanding maybe some basic query syntax, and how that folds in as a developer on the Azure platform. So from a storage perspective, we need to understand blobs, tables, queues, Redis cache, and implications of bringing that into our application. Understanding access control. How do we interface with the storage and keep it secure? Understanding monitoring, SQL DB, search, and of course our files, which we talked about earlier with our virtual machines. So understanding access control. Starting out, you need to know that there is a shared access signature, an SAS. So essentially, you're going to get a token. You're going to request a token from this service. You're going to get a token back, and you're going to use that as your gatekeeper, your unlock code, essentially to go back to that storage from your application. So essentially understanding that there is an SAS token service, you're going to get a token back, and you're going to use that to access your storage. There are some different tools to generate your SAS. So you can use all of these different options. So again, the CLI, PowerShell, we have the Storage Explorer, and the portal. And of course, you can use custom code to generate your SAS as well. We can always do things through the RESTful APIs as developers. Blobs and files. Understanding the key takeaway here is understanding the structure of a blob and file and how we interface to those two storage options. Essentially, we have that SAS token again, and understanding that a blob is inside of a container is inside of a storage account. So later on, I'm going to show a different screen, but we have essentially you need to have an account with a container with a blob inside of it. So those components and understanding how to interface with that particular storage option, the blob. Understanding block blobs, page blobs, and append blobs, those three different options, how they impact your application, and when to use each of those from an app perspective. And on the right, we have our files area. Understand that we're using the SMB interface to access those files from a Azure virtual machine. Again, we can use our RESTful APIs to interface with the files as well. So overall storage, the main key takeaway with storage is not every little last option of memorizing, object size or what have you. The main thing with storage is how do I interface to it? How do I secure it with our SAS tokens, and when do we use those SAS tokens? And understanding essentially how to get to it from an endpoint perspective. Tables, very similar again from a structure perspective as we saw with the blobs. We have our SAS token. We have our entities which are inside of a table, again, inside of a storage account. So we're starting again with a storage account. And we can access these tables using our table client APIs as well as OData. Queues, very similar again. You'll see a theme here, SAS token. With our queue, we have our queue name, and we have our overall entity with our table and then our account. So very similar as what we just saw prior. And our queue has our queue client for our interfacing. So I talked about understanding the different endpoints, blobs, files, tables, and queues. You'll see consistently you need to start with a storage account. You have the account as the first option. Then you have a namespace that you're going to access it. These are the RESTful API URLs essentially. You have your namespace. We have blob.core.windows.net for our blobs. And then as I mentioned, you have your container name and then your blob. So what we need to understand is how to access these. What are the components that I need to access each of these? For a file, I need a storage account and the file name. That's it. And for a queue, I need the storage account and the queue name. Okay. So SQL database, what do I need to know as a developer on SQL databases? So you need to understand that there are different tiers of SQL databases and understanding when they are used or what is their most appropriate use. So for basic, I would use that for dev test. That would be a great dev test and small scale apps. And you'll see this DTUs, the transaction units, essentially is kind of a mix of compute power, memory, disk, all of that. It's a good option for discussing performance. So you don't have to understand really 5 or 10 or 100 DTUs, but understand what a DTU is and how it applies to these different storage tiers. Because again, we're looking at from an app perspective when we're interfacing and using our SQL databases, what does that mean for our performance of our applications as we interface? And understand that you can migrate between these tiers. Okay, so if I start out with a basic tier, I can go up to a premium tier if I want with my application using the Portal, PowerShell, or the REST APIs. So we can migrate between those. And SQL databases can be scaled out using sharding. So essentially understanding what sharding means. and the concepts behind sharding and scaling out my SQL databases. So Azure Storage Service Encryption, SSE, the big thing to understand here is that we're going to be able to encrypt our storage, but we do have some limitations here. The key with the limitations is it does not allow us to encrypt our classic storage or classic migrated. No existing data before it's turned on. So we should turn this on at the beginning. So any of the existent data as we flip the switch on this is not going to be encrypted. And this does not encrypt tables, queues, and files data. This is mainly focused on blobs only. Okay? Correct. It'll leave the data that's there. Anything in the future will get encrypted, but that existing data is not going to encrypt it. It's going to sit there unencrypted. So if you got data in a blob, excuse me, already, and you turn this on, it's not going to encrypt that data. It'll encrypt everything going forward. So Azure Search, how does this play into, as a developer, our overall solutions? So when I use search, I have to understand these key concepts. I have to understand what an index is and how to create an index. I have to understand how to add data to my search, how to push data into the search so that it actually can be indexed and searched, and how to handle results that come back from my search. How do I page through those results? How do I actually handle them and lay them out from a search inquiry? So essentially, we're looking at indexing is that persistent store of documents. We're looking at that overall index. Where do I find my information? And how do I add data? Like I talked about, pushing data with the .NET SDK or your RESTful APIs. Understand you can push data in, and it's JSON data that you'll be pushing in. And again, how do I handle results? What are the actual output from a search page perspective? And understanding how to sort, that you can sort and filter the results, etc. So Redis cache and caching. From a development perspective, we really have to understand that there are different tiers of cache and the performance implications of those different tiers. So we have a basic, standard, and premium. We need to understand optimistic versus pessimistic concurrencies. And when we want to use shared versus private cache for distributed app caching, the data persistence and our clustering. So we're going to set up clusters with our Redis cache. What does that mean for our app performance? Some of the other areas I have links in the lower right for is our pub-sub model with Redis. How do we set up a pub-sub or use pub-sub? And overall caching guidance. So the key takeaway here is understanding the different tiers. When we add Redis cache to our application, what is the impact performance-wise or some of the gotchas, as well as mainly understanding optimistic, pessimistic, and clustering. So Cosmos DB, how does this fit in our solutions as a developer? What we need to understand is that Cosmos DB, the underlying engine there, we have several APIs over top of Cosmos DB that we can interface for our storage. So we have documents, tables, graph, and Mongo DB as well. And understand essentially basic syntax for queries within Azure Cosmos DB for creating and querying the database itself. A big thing to understand as well is that you can expire data inside of Cosmos DB. There is a time to live, and there is a way to actually expire data as an option. And we need to understand essentially how it is scaling and distributing itself globally, and understanding that business continuity aspect of Cosmos DB. So that's it for storage, and moving on to web and mobile. Again, this was our 30 to 40%. This is a large majority of the exam here, was the web and mobile aspects. So from a web and mobile focus, we have the app service, which includes the web apps, mobile apps, API apps, and logic apps. So there's a lot there. We also have API management, service fabric, and functions. So functions with our serverless. So we as developers have to know all of this fun stuff. These are our building blocks. So the Azure App Service essentially makes up these 4 components, as I mentioned, the web apps, mobile apps, logic apps, and API apps. It's a great way to build and scale applications across these platforms. So we need to understand essentially that we've got a PaaS environment that is auto-patching and auto-scaling. Okay? We can run .NET, Java, Node, PHP, Python, all these different languages. And we're going to integrate with our software as a service applications, Salesforce, et cetera, as well as our on-prem applications. And we do have continuous integration. I talked a little bit about DevOps. We're going to get maybe a separate section on the exam. It's not currently there for DevOps and DevOps processes. But there is continuous integration with VSTS, GitHub, Bitbucket, Box, other areas as well. So our web apps. What do we need to know about web apps? We need to know how to deploy them. We need to know how to configure a web application. We need to understand diagnostics around a web app. We need to understand web jobs, our processing, our background processors. We need to understand scaling and our resiliency. How do we keep our web apps up and running and scale them when we have a high load? So from a hosting perspective, the key to know here is that we have a resource group. This is going to group all of our resources. We have an associated app service plan. So from a web app perspective, we have to choose an app service plan. And our web apps essentially are inside of these constructs with our app service plan and our resource groups. So Azure App Insights, we're looking at diagnostics, telemetry, and monitoring our web apps. So we can essentially monitor our web apps, our Java apps, our ASP.NET apps, our Node.js apps, et cetera. We can inject app insights into Windows services, Docker apps, JavaScript, our SharePoint sites. So app insights essentially can be used in all these different scenarios, and understanding that we can create and get metrics out of our application, including custom metrics, if we want to include those. Mm-hmm. It's more from a developer perspective slant of how do I inject app insights into my application to get custom telemetry out. It's less about the dashboard and all of that kind of visuals. It's more from an application perspective and understanding I can get different telemetry out of my app, including custom telemetry. So if I'm a insurance person and I'm processing claims, insurance claims, I can actually create custom telemetry to understand how many claims per second that I'm processing. So it's understanding that I can do those kind of things. And again, this is in the DevOps lifecycle of monitoring. We have this entire detect, triage, diagnose DevOps lifecycle, and understanding app insights fits into that monitoring area. So we're getting that telemetry out of our applications, all different types of applications. Again, not just web apps. This could be Windows services. This could be almost anything. So here's just a couple of different diagrams kind of showing some of the components as they go together to scale a web application. I don't really talk about Traffic Manager too much in this presentation, but understanding how Traffic Manager fits in. So Traffic Manager is essentially DNS-based traffic routing from a networking perspective, and understanding that we can essentially scale a web application globally using Traffic Manager and routing to multiple different locations. Again, we have that app service plan, that construct that I talked about when we have a web app. We need to create an app service plan. Inside of that app service plan, we have our web app, and we have various pieces of the web app. We may have Redis cache. We may have an Azure SQL database. Okay? So we may have some of these components as they come into play. But essentially, Azure Traffic Manager is routing to 2 different hosted app service plans and web apps in 2 different locations. Also, that we can isolate a web application. So essentially, we can use a web app firewall. Again, going into details, this would be more the 533 exam if I had to go really deep in this. But from a developer perspective, understanding that this is an option that we have. Somebody mentioned the ASE, the App Service Environment, earlier. That ASE isn't an option. Why? Why do I use an ASE? Essentially isolating our web apps. This would be mainly for intranet scenarios or scenarios where you want that security and you want to isolate your web applications. This is why. So on to mobile. Adding mobile features onto a web app. So mainly here, this gives us a diagram, again, showing us kind of the components of adding those features to a web app. We have a notification hub. We possibly would have a NoSQL storage area. Again, hosted inside that app service plan, we have our web app, we have our mobile app, and an API app used to communicate. The main thing here, understanding when would we want to add these mobile features to a web app. Maybe we want to add push notifications. Maybe we want to add offline data syncs. We have our mobile app that is disconnected. So understand how to do that. Web jobs. Web jobs are essentially run in the process space of a web app, but are used for scheduled or on-demand processing. A lot of a default example would be if you wanted to manipulate images that are in your web app. You want to make thumbnails. That's the typical example. You would have a web job that would essentially go out, read all of those, pull in all those images, and then resize them. So it's essentially a background processor that could be on demand and or scheduled. Mm-hmm. Yes. Now. Yep. Yeah, and this is an interesting period with transition because functions are becoming more and more prevalent, and Donna and her team are doing a great job, enhancing the capabilities there. It has been debated whether or not to keep web jobs on the exam. As of today, right now, web jobs are still viable, are still a solution for a background processor. Functions, the reason I point you to a web job too is right now, functions cannot be scheduled technically as web jobs. So you can't schedule them. So any of that scheduling or on demand, you could use a function, but I'd still point you to the web jobs. Yep. So how do I create a web job? Go ahead. Yes. If you take the exam in a few months, and yeah, if functions isn't on there, good point. Yes, web jobs would still be the processing. I did actually ask Donna and her team if that's kind of where it's headed. As a developer, I think that's where things are headed. I don't have the options, even though I'm all the information, even though I'm with Microsoft. I don't work on that team. But it seems like to me things are headed towards functions. But web jobs, again, is still very viable. You can use them, schedule them, create them, etc. Yes. Yeah. Okay. It's just to repeat. You said that one of the sessions they said everything's going to be functions essentially, and moving that direction. That was the hint that I had. But again, from an exam perspective, web jobs are still on there, and that may change in the next few months. And the thing, again, if things do change, always go back to that skills measured, the very first link that I talked about. If you go out and you look up the 70-532, you'll see that skills measured. That is what's going to be on the exam as of today. So always use that as your guidelines. So to create a web job, you're going to upload in a zip file some code of some sort. It could be Python, PowerShell, Java, some .NET. You're going to zip that all up. You're going to upload that. And to schedule it, you're going to create a settings.job file at the root of that zip file. It's going to contain essentially your schedule if you want to schedule it. You can also set on demand in launch your web jobs as well. Or you can just use the Azure UI. So here we are in the portal and configuring a web job. And again, we're going to upload our zip file. We're going to name it, and we're also going to tell it how to run, either continuously or scheduled. So here we go into functions. Essentially, we have code and events plus data. So this is our serverless focus, is Azure Functions. The big thing to know here from a developer perspective is functions run in the same processing space as web jobs. They run in the web app processing space as of today. They are asynchronous, event-driven, serverless. So we're looking at our serverless experience. They do have various, you can respond to events coming out of, say, Salesforce, Office 365, even your on-prem systems. So this is responding to those events. And you only pay while the function is executing. It is fully open source, and there are direct integrations with Logic apps. Yes? Also pay when it fails? Yes, that is correct, because it was using computing power. Good point. So yes, if your function does run and fails, yes, you still pay. But it's essentially that you're paying for the compute. Good point. One thing to understand with functions is those triggers and those bindings. So understanding when you can trigger a function and bind to those various events. So as a developer, I would want to go out and build a custom binding or understand when I could key off of various events and triggers. So those would be good questions I would ask. And I would probably make you do a little bit of code here, at least drag and drop some code. So microservices, modernization with microservices, right? We've got these individually built and deployed units of work. We've got our web app, our business logic, our data. We're kind of breaking things up. Essentially, what we're looking at here is our microservices platform. And for us on Azure, that is Azure Service Fabric. So understanding Azure Service Fabric is our microservices platform, and understanding the fact that you do have lifecycle management. It's highly scalable. Essentially, you have a cluster and nodes associated with Azure Service Fabric. From a developer perspective, I would understand what this means deployment-wise, when to use this versus when not to use this, possibly. Understanding also Azure Service Fabric can run on-prem or in the cloud. So I can actually run this on my desktop or on a server if I wanted to. It does support stateful services, containerization, and Docker containers. So we do have Docker in orchestration, container orchestration across the Service Fabric. And again, mention multi-cloud. It can run on any cloud platform. Again, it can run on-prem on a server, or it could run across any other cloud platforms. And it is the deployments, the upgrades, all of that is built in. You can essentially deploy to a particular node and have it upgrade across your entire cluster. So again, with Service Fabric, understanding how to build and deploy your microservices. The focus here, there is a reliable actors state management, understanding the actors-based service. There are some concepts in there, especially around reentrancy and partitioning. I would understand what it means to partition on Service Fabric, or what reentrancy means on Service Fabric as a developer. Understand again that you have containers and that you can host containers across Service Fabric, and that you can run guest executables. So essentially you have an executable, you can deploy that to Service Fabric and have that running. Understand again from a monitoring and diagnostics perspective that you can get information out of your Service Fabric clusters. And understanding the scale, upgrade, and security around a Service Fabric cluster. So from a development perspective, it's more of when would I use this, when would I not, how do I deploy to it? If I were to push out a new upgrade, what does that mean for my overall nodes? How does that actually impact my Service Fabric cluster? So here, what I would suggest, go out, use the portal, deploy a Service Fabric cluster, and then create a small microservice and then deploy it. That could take you 15, 20 minutes or several tutorials, and that will get you 90% of the information you need to know for Service Fabric. Cloud services are still on the exam. It's our original PaaS offering. From a cloud service, essentially understand that we handle the underlying VM patching and all of that fun stuff. And it is, as I stated, our original PaaS offering. With a cloud service, the key components to understand are the worker roles and the web roles. So you have these two constructs within a cloud service available to you. And most of the time, this is a cloud service would be used when you need some form of the VM access. So you don't actually get access to the underlying VM with regards to OS patching, but you can still remote into this and actually, if you needed to host something that is needed on top of the VM in particular. Yes? Yes. Best practice, avoid cloud services at all costs. And they're still on the test. I reached back to the product groups. Yes, they are, they are still used by several customers. Putting on my Microsoft hat, please avoid these at all costs. Like if you're building a brand new solution, do not use a cloud service at all, please. Please just stop using these. We actually have on the exam mainly migration away from a cloud service. Okay, this is how to migrate from a cloud service. There's an excellent article out there on the doc site that actually tells you step by step how to migrate from a cloud service. And if you're not familiar with this process, it's actually pretty straightforward. You just bring your cloud service down as a developer, you make a few code changes, recompile it, and push it back out. Now, where do I push it back out to? Service Fabric could be an option. Yes. Yes. That is true. Yeah, I'm speaking from newer. If it is older framework, yes, I'm making it sound overly simple. Yes, this is not a 10-minute process. I'm making it sound 10 or 15 minutes. If it's a newer code implementation, newer .NET framework, it's about a 15-minute process. Older, no. Yes. 3.5, a lot more effort. Yes, absolutely, absolutely. Correct? Yes, yes. Depending on the versions and what you're trying to accomplish. But I do advise, understand what a cloud service is, and essentially kind of migrating from a cloud service. API management. So what do we need to understand about API management? Essentially, we're hosting our APIs. This is a great time to have an API that you wanted to essentially throttle API calls. Maybe you have an API to a customer and you want to charge that customer for the number of API calls. So it's understanding those key concepts. You have various policies that you can apply to your APIs. You can rate limit, again, the throttling around your API. You can add caching to it. And you can customize a developer portal. So again, a developer's consuming your API. You can create a custom portal for that developer. And then there is an API inspector for tracing calls to API management. So API management essentially is the combination of that API gateway, a developer portal, and a publisher portal. So we're creating APIs and publishing them out there for other developers to consume, essentially. So on to our last section, identity and network. So that was all web and mobile. And moving on to identity and networks. What do we need to know as a developer regarding identity and networks? So from an identity and network perspective, we have Azure AD, AD B2B and B2C. We have to understand when to use those or what those concepts are. Our communication mechanisms across our networks, and messaging. Messaging kind of falls into this area with our notification hubs, etc. So Azure Active Directory. I always hated that Microsoft named it the exact same because Azure Active Directory is not Active Directory on-prem. Very similar concepts, essentially a whole different product. So Azure Active Directory, understand that that's your cloud option. Active Directory is your on-premise option. And to get your identity from your on-prem to the cloud is AD Connect. Okay? We're going to use AD Connect. We're going to run this, and it's going to push essentially identities and match that up in Azure Active Directory. From a development perspective, I'm going to use Graph to query Active Directory. You've heard a lot more about Graph here at Ignite. And essentially, we're going to use Graph to query Azure Active Directory for those various identities. And it's depicted here. We have Exchange Online, SharePoint Online. Anytime, this is just a side note, anytime we do set up a SharePoint Online, Exchange Online, you set up a separate tenant for your Azure Active Directory. And essentially, we'll have to have those tenants talk to one another. The main point to understand here, we're going to use the Graph API to query our identity with Azure Active Directory. And we can connect our Active Directory on-prem to Azure Active Directory. You'll notice, again, on-prem, we're going to use LDAP to query versus the Graph API. ADFS is, Federation is, understand that concept, but as of today, no. It's not particularly prevalent on this exam. If you're looking for ADFS questions, they would be on the 533. Correct. And the statement was, just to repeat, moving away from ADFS and that concept, moving straight to claims and not having those on-prem ADFS servers. They could be down, all that good stuff. Yeah. Hopefully no on-prem dependencies. Not that we can completely move away from on-prem. But it does support this hybrid scenario of on-prem AD to Azure Active Directory. And we're using AD Connect essentially to match that identity in the cloud. So we have this concept of securing our resources using managed identities. Again, we have that programmatic access using Graph API. So understand if we're looking for identities in Azure Active Directory, we're going to use Graph API. Understand OpenID Connect and OAuth. When would we use OAuth for access authorization role-based assignments from an application perspective? We'll talk a little bit more or go into more depth on OAuth in the B2C scenarios, but it's understanding essentially OAuth. I would look at the OAuth process flow. So I'd go out and look at how does that impact my application? How do I input OAuth into my app for that access authorization role-based assignments? So essentially, it's just taking you through what it looks like from a local directory and setting up directory sync. We can activate, deactivate directory sync using the portal. So B2C, our business to consumer scenarios. Again, we can use OpenID Connect at the bottom there. We see the orange box OIDC, OpenID Connect and OAuth 2 for protocols. Essentially, this allows us to allow those social and local accounts. So if we want to connect our Facebook account, our LinkedIn account, our Twitter to our application, be that authentication authorization source or auth source, and then we can authenticate them and have them authorized to our application. So it gives that seamless user experience. Understand with B2C, we also have MFA, so we have that multi-factor authentication. So if we want them essentially a secondary factor on the phone or another device, we have that as a capability. So from a development test perspective, understand B2C, that we've got different protocols. When would we use this? Okay. So B2C versus B2B. Essentially, B2C, we're looking at OAuth and our integration with Twitter, Facebook, etc. B2B is our business to business. It's on behalf of a particular business. So we have different concepts. Partner organizations, collaborators would be our B2B. Consumer-facing, citizen-facing would be our B2C. We'd implement OAuth in B2C. And essentially, those are kind of the key differences between those. So it's understanding when to use B2C and when to use B2B. So service bus, we have to understand queues, topics, relay, and notification hubs, and kind of the differences between those and when to use one versus the other. Our first in, first out, our FIFO queues, that we've got a client there. If you're looking to essentially host a WCF or leverage WCF, it would be from a relay. So understanding that, that'd be a good question. Where, when would I use WCF? It'd be in the relay. And our push notifications, where's that at? That's in the notification hubs. Okay. So our service bus queues versus storage queues. Service bus queues are first in, first out guaranteed versus the orders not guaranteed in an actual storage queue. So we're talking about Azure storage queues versus a service bus queue. And a service bus, we're going to deliver once and only once. With storage queues, we can deliver, at least once, maybe multiple times. So it's understanding from an app perspective when to use an Azure storage queue or a service bus queue. Okay. New feature that was recently announced, Event Grid. The main key to understand what the Event Grid is the concepts with event publishers and handlers. Okay. So we have all of these publishers, and then we're going to handle these events using functions and logic apps and Azure Automation and webhooks. So it's understanding when to possibly create and route custom events as a developer, I would want to maybe create a custom event. I want to look at the code around that. So that would be a key with Event Grid. So that's a newer feature on Azure. Another thing that was recently actually added to the exam is a lot around Key Vault. So understanding, we talked a lot about our SAS tokens around the storage. That is our token to access storage. This is an area that we can keep those tokens secure. So essentially, Key Vault, we're using it to secure those tokens. We may even have app permissions or secrets or things like that, like connection strings, et cetera, that we want to keep. We can keep those in Key Vault. This is our secure area to keep those pieces of information. We want to store certificates. We want to store those SAS tokens, those kind of things. Key Vault is your area. And you can actually create and bring your own keys over as well. So if you have your own set of keys that you want to bring in, those are known as the HSMs, the hardware security modules. That's essentially you're bringing your own key tied to that HSM boundary. So this is where we would keep application keys, tokens, and here's a couple links again that talks about using those keys from a web application perspective. Another concept to understand is in the key rotation and auditing. So we want to keep those keys constantly possibly changing, like your garage door opener. It's always changing that key. And this particular example actually uses web jobs to rotate those keys. What's that? And it's not secure to use web jobs. Okay. Yeah. So again, go to functions if you can. Yeah. So you're talking about securing the certificates and renewing them. Some of the steps are a little bit old because you can renew with some CAs and some you cannot. Hopefully the documentation's up to date, and hopefully we got the exams up to date regarding that. From a development perspective, though, what I would want to know as a developer when I'm being asked on this exam is when to use Key Vault, when not to use Key Vault, the fact that I can use key rotation and auditing to keep those keys up to date, secure, and essentially that I can bring my own key and that I can access these keys using a web app or other application constructs. So that would be the key focus. What's that? And the costs, yes, pay per read. And speaking of costs, real quick on Azure, there may be some questions around, hey, how do I keep the costs down? There's 3 components of Azure cost. And I go to my customers and I always talk about this. Compute time, storage, and egress traffic outside the network. Not uploading into a network, but outside, pulling it outside of the data center. So if you want to talk about costs, it's always those 3 components. Compute time, storage costs, and then our egress traffic. It always breaks down to those. So you go out to the Azure calculator, you run your numbers, it's those 3 costs that you're breaking down. So study strategy. Overall, I tell you, go out to the portal, go get a subscription, use this stuff. Actually do it. Get hands-on with it. The docs site, our Azure docs site, the docs team has done a great job. I know it's boring to sit and read documentation, but we have some labs, some videos. The Azure docs site is a great resource. I highly recommend it. So go out there, start pouring through some of these things. You know nothing about web jobs or you've never really written a function. Go out and look up functions and watch the videos around those. You learn a lot of information quickly. Microsoft Virtual Academy, there is a couple of MVAs that I suggest. There's talking about, if you've never taken a certification exam, the first link talks about what's in the exam, different question types, kind of walks you through that process. And then the second one is the 532 MVA that I recorded prior. Yes, and it is old. So you're getting the newer information, but it has some other good information and good links as well from a previous session. Born to Learn.mslearn .NET is your focus for study groups. There are several study groups up there. Folks, I encourage you to collaborate. Do not share any information about what you saw on the exam. You're not allowed to, but you are allowed to share information around any of those topics. Like I talked about the skills learned, share all the information you can around functions, around web jobs, around what have you, to help one another. The measure up, I know we have free practice tests here at Ignite. Use these as a guide. A lot of folks give me feedback, measure up's not up to date with the exam. Again, the exam's rolling every 3 months. Measure up's doing their best, but use this as a guide. If you're acing the measure ups, don't feel bad when you go in and bomb the exam. But if you're getting destroyed by the measure ups and you're like, I'm an idiot, and you go take the exam and you pass, So I've had, similar success with the measure ups, but use these as a guide to help you get into that process thinking around an exam. We do have edX course and labs as well. I suggest hands-on. I'm a very hands-on person, but edX is our platform of choice for our hands-on labs. And there is a course if you're like to do in-person, teaching, instructor-led training. We do have a course, 28532C, for any of the MCTs. If you want to attend an MCT type course. So real quick, I know I'm over a couple minutes here. Case studies. These are those business areas that I was talking about with several other questions that are associated. My advice, I don't like to read a lot. I would scan the case study, essentially look down, map the items back to the case study. At the end of the day, the information is in that case study. It's required that we actually tie back the information back to the case study. So it's going to be in that case study. Your answer is going to be in that case study, but you're going to have to understand, of course, the technology associated with that, but it's going to be there. So that's my advice. Maybe you don't have to read the entire thing right out of the gate. If you're a fast reader, that's great. I'm not. I usually look for themes and try to get an understanding of what that business case is, and then I go to the item. And then I go back to the case study to figure out what in context is that particular item. So that's it. And hopefully, please evaluate this session. I appreciate you coming out. Appreciate your time.